Ladies and gentlemen, we're going to conclude our exploration of nuclear magnetic resonance spectroscopy. This is what it's going to look like on your tests. I believe we did one similar to this on our virtual day. And here's a new one. Here's your short forms for these patterns: triplet, doublet, doublet of triplet. What else do we got? We have some infrared information. A molecule has this formula and an intense infrared absorption at 1711 reciprocal centimeters. Wow, that's fancy talk. And it means has carbonyl. Useful information right there. We got useful information there. I don't have any benzene information. You notice that? I look over here. If I see peaks in around 7, I get excited because that's like 6 carbons for benzene, and that's a chunk of a molecule every time. We'll have to work with what we got, right? I need to get my chart. So let me stop the share and get my chart. And we're back. Celebrate a little bit. We got our chart right over here on the right. I know it's a little small, but it's got everything we need. Get my mug out of the way here. What else we got? Well, when I see 6 H's, I like to start there too, because that's 2 methyls almost every time. Identical methyls, so they have to be attached to similar things. So I just write 2 methyls right beside each other, above and below each other, whatever. And we're talking about B here. We got methyl attached to something, another methyl attached to something. It might be that same thing they're attached to, the next carbon. We don't know. This could be a big old C here that they're attached to. I don't know. What kind of pattern are we talking about? A doublet. Oh, this is your traditional isopropyl. What is he talking about? You'll see the pattern with 6 H's all the same, and they're a doublet. That means they're connected to a carbon with how many H's? 1 H. And this is kind of the scenario I was just talking about. I'm just going to make it look better. Here's the carbon with the 1 H. And that's, if you look at it, that's an isopropyl group, isn't it? Yeah. And you're going to get full credit for the 6 H's in B right now. Let's put a B here. Don't forget, that's the, label B. This B means we're thinking about B to get to here. Let's try to hunt this one down, shall we? It's 1 H, that's kind of unique. And there's not too many options for 1 H. There's 1. And we've already accounted for 6 of the neighbors, haven't we? 6 of the neighbors are here. We have to get up to 8. How do I know we have to get up to 8? Nonette. It's a CH2 next, isn't it? Oh man, I love when this stuff happens. CH2 in hot pink. And the nonette is letter D. So now we have 2 points for D. Pink is 3 possibilities, right? CH2 that it's pink, because we have 2 H's 3 times. So I'm not going to jump to any conclusions on that yet. But I do see something where the teacher's really trying to help me. Whenever I do this, don't cringe, say thank you. Because not only does that give you information, it gives you information about neighbors on each side. On one side, there's 1 neighbor. That caused a doublet, right? And on the other side, there's other neighbors that caused a triplet. So there's 2 of those neighbors. Okay. Yeah. So this may be the pink, but I don't know that yet. I don't want to jump to that conclusion, but let's just work on this by itself. And then maybe it ends up being this CH2. I don't know. Red for the letter C here. Doublet of triplet, 2 H's. So the red would be 2 H's. And we're working on C, and on one side, don't want to give, we have to use new colors. On one side, it's one neighbor. That would be a doublet. And the other one is two. That would be a triplet. And that would be C down there. I can't give you points. I might give you some points for that because this is clearly an octet violation here. You can't just leave it like that, is what I'm saying. But if I can tell you're in a hurry and you just left this on the page, I'm going to give you the 2 because this is probably where you left off. That I got to move on. Okay. All right. 4.3 is a nice number. I mean, we got to be looking at electronegative atoms, don't we? To get it up there. And we're not looking for fluorine, not with absence of fluorine in the formula. And some of you might have figured out Dr. Whitaker seems to really like esters. He does. I mean, for real. I mean, just not in just doing these problems because esters are a cool functional group. I got a nice handout back there with a lot of esters. You see the interrelationship of similar esters and different flavoring agents. I'm just going on a little bit. I'm sorry. But esters are cool. So I like to acknowledge that. I'm thinking esters because 4.3 is down here. Sorry, up here. 4.3 would be in there. And we can make that work as long as there's 2 H's attached to a CH3. It could be an ethyl ester is a thought. What does he mean by that? Okay. Let's go with green. We use green. Running out of colors. Highlighters. Come on. Don't be dead. It's dead. Okay. This is disturbing. Light blue. We're talking about F. We're thinking strongly it's an O attached to a CH2 for F that has 3 neighbors, so some kind of CH3. And make sure you make it an ester or else you don't have the right shift. We got that going on. Very lame carbonyl there. And then I ask myself, that CH3 I drew is a dead end. I better have something that fits it, right? Does A fit it? I think A fits perfectly, right? You can label it A. I'm going to give it to you. So let's do an inventory. A's taken care of. B's taken care of. C's sort of taken care of. I'm not going to cross it off. D is done. F. So we're CH2 short probably with guys 2.4. I've been doing this a long time. As soon as I see a 2.4 and I know there's a carbonyl, I'm just going Greek. I'm saying alpha. If there's a carbonyl in a molecule, there's a very good chance there's a carbon next to it. And we now know that's a special carbon called alpha. And alpha has nice numbers that are very easily spotted in NMR. They're down here, alpha. Let's give you a reminder, these are alpha. One away from a carbonyl, and that fits our 2.4 very nicely, right? If it's the internal one at the bottom instead of the terminal one. And 2.4. So this carbonyl, we know something about Mr. Squiggle now. And here's Mr. Squiggle coming up. Here's carbonyl redrawn. Here's the other side of the carbonyl. If it's 2.4, it fits there. If it's attached to a CH2, it fits. It's a triplet, right? Is this going to be E? And that's our pink triplet. So you're going to love this. Watch. Yeah, you didn't like that at all. I know. It needs 2 neighbors, right? And this, he better fit something. I don't know what he's gonna fit. He's the doublet or triplet guy that we never really finished with. We just, wait, C. Okay, that really was C. Look, it fits everything that C says. CH on one side, CH2 on the other. Look, it fits, this thing fits. This may be confusing if I try to do it this way. I'm gonna go gray here, ambiguous gray. It lets me use a pen. That CH2 is this CH2. We figured out just now. And might as well finish the molecule because we had it drawn over here, OCH2, CH3, and just as we're finishing it off, make sure all the letters are on this one. And they are. A, B, C, D, E, F. So here's our answer. This lovely molecule right here. There we go. And that's it.